by the time we finish praying, I believe will be like 100. Then we can start. Who can lead us in our word of prayer for today? Yes, Daniela.
Am I praying now or when we get to 100?
You can pray now. They will come.
Okay. Let's humble ourselves for the prayer. Lord Father, we thank you for today. We thank you for the gift of life. Thank you for the lessons that we have had today. And Lord, even as we learn, may our connection be good. May we understand each and everything that the teachers are going to teach. May you protect us and cover us with your precious blood, even as we go through the rest of the day. Thank you for all this, I believe and pray in Jesus' name. Amen.
Amen. Amen, amen, and amen. We are now 88. I think we can share and start. Let me share my slides and we can start. Okay, girls, we are going to start on a new topic, acid, bases, and salts. Okay, are we ready? I see we are 99 people, so that means we are 100. We can start. One person will join us. 102. So let's start. So when someone says acids, I need all of you to tell me what you think when someone says acids in our real life. In our real life, when we
Teacher?
say acids, what comes into our mind? Yes. Daphne, you can start.
Something that can burn. Something that can burn. That's what I think about.
Daphne, we couldn't hear you.
When I hear acids, I think about something that can burn.
Something that can burn, just burn when it's put
When
in
it
fire.
goes into
When
contact
burned,
with
we
your
can
skin.
burn its own. With your skin. Okay, thank you very much. Another person, Shona.
When I hear acid, I think of a certain chemical, like a chemical, like a dangerous chemical. Yeah.
Dangerous
Teacher, can I
chemical.
try?
Okay.
Teacher, may I try?
Chemical. Okay, next. Let's get Daniela.
I think an acid is a corrosive substance that has somewhat a composition of hydrogen, and it can turn litmus paper from, I think, is it from blue to red? That's what I think.
Okay, very, very much. I believe by the end of this topic, all of us will be on the same page. I need us to continue telling us,
Teacher, can I try?
what do we understand when someone says an acid in our daily lives? I see Dove, I see Jovia, I see Nicole, I see Kadu. Okay, in that order. Dove first.
Teacher, I think an acid is okay. What I think when I hear an acid is something with a low pH, like from 1 to 3 or 4, things like that, and a chemical that
I didn't hear the
turns a
point very
little
well.
red. Teacher, can you hear me? Teacher, can you hear me?
Yes, I'm hearing you now. Litmus separate. Thank you. Next person. Yes, I heard you to read. Thank you. Next, is that Jovia now?
Yes, yes.
Mhm.
So I think an acid is a compound that produces hydrogen ions and also conducts electricity when it aqueous form.
I've had conducts electricity, had has hydrogen ions. Girls, you need to keep noting down all these points that our friends are giving us because they are all correct. In our daily lives, what do we know? When someone says an acid, what comes with your mind? Next, Nicole.
An acid is a proton donor.
Nicole, you're breaking. Either it's me who is not hearing. Students, are you hearing Nicole?
An
Yes.
atom is a
Yes, teacher.
proton donor.
Yes,
An atom is a proton donor. Thank you. Next item, we go to Kadu. I'm remaining with 5 students, then we can start studying. I need to first understand what you think of acids.
A substance with a sharp sour taste.
Sharp, sour taste. Maybe on that note, have you ever tasted a lemon? A lemon fruit?
yes.
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 Okay, that's sour. Okay, then I'll talk about it. Thank you very much, Kadu. We go to Lindsay.
An acid is a product of a reaction between water and a nonmetal.
That is too much chemistry for me. But thank you very, very much. It is okay, okay. But for now, I need you to remember we talked about acids when we were comparing radicals, valencies, and formulae. Someone remind us, if you remember those notes, what we studied. When do radicals form acids? Then I'll start. When do radicals form acids? By show of hands. Yes, Jovia.
So I think radicals form acids when they react with hydrogen.
When they react with hydrogen, is she correct? Your hand is up.
By the removal of hydrogen.
Hydrogen, thank you. So from what you, okay, I have 2 more hands. I'm going to pick the last 2 people, then I'll start teaching. Paula and Shona. Paula, Shona, then and Grace. Unmute yourselves. Pick if you have another point, then we go. Yes, Paula.
When radicals react with oxygen, so they form acid.
Radicals reacting with oxygen. No. We said when radical hydrogen,
Oh, okay.
and in that case we call it hydrogen ion because it has a valency. We call the products acids. Okay? So today we are going to look at those acids, those substances, or those chemicals that you've told me they are sour, they can burn your skin, they can burn someone's skin, all those that you've told me, those are the acids that we are going to look at. So now in chemistry, I'm going to go into the chemistry world very fast. Then later I'll come back to your real life. Where do we expect to find acids? Now, if you can remember radicals, I'm going to give you 3 radicals, then we remember the acids that we formed. I'm going to use my screen. We said if we have hydrogen and a sulfate, what was the name of the acid formed in this case?
Hydrogen
Mercy.
sulfide. Sulfuric
Next
acid.
person. Sulfuric acid. Do you have another suggestion? Sulfuric acid. Thank you. We said if we have hydrogen with a valence of 1, those are hydrogen ions, plus a chloride, which as this is 1 and this is 1, we don't write ones, okay? What is the name of this acid? By show of hands. Let me see.
Hydrochloric acid.
Ivrin and Zora, what do you think? Which acid are forming?
Hydrochloric acid.
Hydrochloric acid.
Perfect, Zora. Let's go to a carbonate. A carbonate is reacting with hydrogen ions. Carbonate has a valence of 2. What name of the acid do we form in this case?
Carbonic
That is,
acid.
I'm seeing Charity.
Carbonic acid.
Okay, thank you. So now I'm going to tell you the names of valencies, the names of the different radicals. You just tell me the name of an acid. I think you have that table. If I have sulfite, what is the name of the acid? But a sulfite. You see the number of high oxygens attached to sulfur. That number has changed. What is the name of the acid formed when you have a sulfite? Yes, Kadu.
Sulfurous acid.
I didn't hear you. I didn't hear you
Sulfurous
very well,
acid.
Kadu.
Sulfurous acid.
Sulfurous acid. Thank you very much. The valence. Thank you very much. The valence comes here. We have sulfurous acid. Next, if we have are phosphates. What is the name of the acid formed? We have a phosphate. Its valence is 3. By show of hands, we talked about them. Need someone to remind us. If
Phosphoric acid.
has talked, Esther. Phosphoric acid, and they write it as this. Maybe lastly on this note, then the 3 is the valence that has come on. Then lastly, when you talk about a nitrate, it has 3 oxygen atoms and its valence is 1. What is the name of the acid formed from a nitrate?
Nitric acid.
Nitric
I
acid.
see Lindsay. I need someone else to talk. Okay, thank you, Lindsay. Nitric acid. By the way, to summarize this topic, these are acids. From these examples that I've put on our screen, what is special about acids? Those who can observe very carefully. What is special about acids? What do you see that you find in all acids that are put on my screen? Grace and
They have hydrogen ions.
yes, all of them have hydrogens in them. You see, every time they say an acid, it means that they have some hydrogen in them. You see, let me get another color. Here we have hydrogen in sulfuric acid. We have hydrogen in hydrochloric acid. We have hydrogen in carbonic acid. We have hydrogen in sulfurous acid. We have hydrogen in phosphoric acid, etc. All acids have hydrogen. But remember, since it's not hydrogen gas, the diatomic molecule, we say that is called a hydrogen ion. So in solution, we always have a hydrogen ion. Now we are going to say that the radicals are negatively charged, then hydrogen is positively charged. That's why radicals combine with the hydrogen because it is positively charged. Okay, so the main point that I need us to pick from here is that all acids have hydrogen in them. And what is it? It is hydrogen ion. That's point number 1. Have we noted that, all of us?
Yes,
Yes.
teacher.
Number 2. The acids that we're going to look at
I beg your
mainly.
pardon on point 1.
Point 1, I'm saying that all the acids that we've looked at, they have hydrogens. They have hydrogens in them. So every time they say this is an acid, it means that it has some hydrogen in it. And we say that since radicals are negatively charged, that means that the hydrogen ions, the hydrogen that they are reacting with is positively charged. So later we're going to say that hydrogen ions are positively charged. Okay, that was the first point that I need us to note today. All acids have some hydrogen ions in them. And you've seen that they all come from radicals. So you see that our previous topic is needed in everything that we're going to learn in chemistry. I'm going to clean my screen. Is that okay? I'm going to clear everything on my screen. Okay. So that means that when we say an acid, when a substance is dissolved in water and it produces hydrogen ions, then we say that that is an acid. From all the examples that we looked at, we had radicals and hydrogen ions. Every time we say we have a substance and when it's dissolved in water, it gives us positively charged ions, which are hydrogen ions. We call that an acid. Okay, have we noted that? Our main point was to know that we have acids and all acids have hydrogens in them. Then, the next point that I need us to pick today, ions are from two sources. Some acids are found in nature. Other acids are, I would say, are manufactured in laboratories. You sit down, you prepare chemicals, you form those acids that we call mineral acids. Some books say or call them laboratory acids. It depends on which book you're using. Other books call them mineral acids because most of the radicals in them, their names, they are like minerals. When they say rocks have minerals, they are sulfates, carbonates, all those radicals, you find them in real life as minerals. That's why the name is called mineral acids. In real life, if we talk about like a carbonate, someone talked about carbonic acid. The examples that we had, carbonic acid, carbonate is a mineral, sulfate is a mineral, etc. Then organic acids, these are found, I would say, man-made. They are found in nature. So before we go to something else, I need us to think of substances in real life or things in real life where you think that we have
Excuse me,
acids.
teacher.
Maybe fruits. I'm going to give you one example. Yes.
Teacher, I beg your pardon. You said that mineral acids are also known as laboratory acids, or you said organic acids.
Oh, thank you. Mineral acids can also be called laboratory acids because for them they can be prepared by chemists in a laboratory. But organic acids, these ones are found in nature. It's an example of lemon here. When you start taking lemon, even lemon juice, it is so sour. So that means that there are acids in that lemon. So I need us to think of these substances, these, I would say, fruits that we eat, meals that we eat, substances that we take, juices that we feel they are sour and we feel that they contain acids. Let's talk about them in our real lives, in our day-to-day lives. Where do you think we can find acids? May I have given you an example of lemon. So I'm going to pick. I see 5 people have raised up their hands. There are more than 5. Every person will have a chance to give us a point. We're going to start with Noela Kesime. In our daily lives, what fruits do you take or substances or drinks? You take them and you feel they are acidic or they have acids. Noela, start.
I think orange, but then I didn't raise my hand to answer this question.
Orange.
I wanted to ask a question.
Yes.
I'm wondering how hydrogen has positive ions, because isn't hydrogen a non-metal, and doesn't it like receive electrons instead of lose electrons? So then how can it have a positive ion?
Okay, thank you very much, Noela. Students, I'm going to answer Noela's question, but she has given us one answer, orange. Then after answering her question, we'll continue. If we go back to the periodic table, what we studied, we said that hydrogen can exist in group 1. It can also exist in group 7. when it's existing as group 1 element, it is behaving as a metal. So it will lose this 1 electron to form a hydrogen ion, which has nothing, and it is positively charged. If I remember, when we're talking about dative bonding, we used hydrogen ion, where we said that the hydrogen loses its 1 electron in the outermost shell, and it remains as hydrogen ion, which has nothing in terms of electrons. Then I remember we said when it's combining with other substances, it goes with nothing because it has lost its electrons. So in this case, hydrogen is behaving as a metal, group 1. Then hydrogen behaves as a non-metal when we take it to be in group 7. So in acids, hydrogen behaves as a metal. That's why when it is combining with these radicals, it will be having a positive charge. We are going to write equations and we'll talk more about it. Is that okay, my dear friend?
Yeah. So is
Okay.
I'm also I want to ask, is hydrogen the only one that can be in both groups, or are there other elements that can also be in both groups, like in 2 different groups?
Oh, okay. For our level, senior 1, senior 2, up to senior 4, we studied hydrogen only. It's only hydrogen that we have that can be in group 1 and group 7. Actually, if you even read books, you see many periodic tables, they put hydrogen on the left hand side in group 1 and even on the right hand side in group 7. Some textbooks. Other textbooks just write it. So you need to note that it is only hydrogen.
Teacher, could you please re-explain that?
Oh. This is
Excuse
group,
me, Mr. Sir.
a minute. This is group 7. This is group 1. Group 1 elements have 1 electron in the outermost shell. 1, 2 to 1, 2 to 8 to 1. You see? Then group 7, they are missing 1 electron to be full. We can have 1, we can have 2 to 7, we can have 2 to 8 to 7. That means that if we are dealing with group 1 elements, this hydrogen can lose 1 electron and become stable. This metal, which is lithium, can lose 1 electron and become stable. This sodium can lose 1 electron and become stable. Those are group 1 elements. So when hydrogen is behaving as a group 1 element, it will lose like others to become this positively charged hydrogen ion. Then, when hydrogen is behaving as a non-metal, it is in group 7, where you see that if this is fluorine, it will gain 1 electron to become stable. Chlorine will gain 1 electron to become stable. Even hydrogen will gain 1 electron to become stable. So hydrogen can either behave as a group 1 element, it can behave as a group 7 element. But in acid, it's being taken as a group 1 element. So it's forming hydrogen ions which are positively charged.
Teacher, so you're trying to say that if like an element has 0 electrons, it's still stable?
Yes, it is very stable. Okay, thank you very much. It is stable, however much it's not perfectly stable, so it will not react, but it is stable because we don't have
Excuse
a
me.
shell which is not fully filled. Okay, students, let me continue with the examples of those
Excuse me, Mr. Sir.
groups. Yes.
I was wondering, so everything that's an acid has a hydrogen ion.
Yes.
Oh, so that means everything that's an acid can be used in some sort of way to make water.
I would say yes, because we're going to look at chemical reactions. That possibility is there.
Okay, thank you, sir.
You are welcome. So we are looking at those substances, those fruits that we have in our daily lives that we feel they are acidic. Yes, by show of hands. I see very many hands. Let's start with Akelo Daniela.
We have apples.
Apples. Then Daphne.
Teacher, I wanted to say apple cider vinegar.
Vinegar. Yes, Zora.
Grapes.
Grapes. Thank you, Destiny.
Sour milk.
Sour milk. Yes. Sarah.
Lime.
I didn't hear that.
Lime.
Okay, lime. Okay. Irene Bukenya.
Pineapples.
Pineapples. Johanna.
Baking soda.
No. Baking soda, no. Okay. It's okay. Let's continue. I'm going to summarize them for you, so it's fine. Stepta.
I don't know. Hydrochloric acid in the stomach.
Hydrochloric acid in the stomach. Yes, it is present in the stomach, but that one, it's not like, I would say, from plants. That one can even be manufactured by chemists. So we're going to say that that one is on the other side of being a mineral acid, because a chloride is a mineral. Okay, yes, it is also found in our stomachs, yes, but for it later we're going to say that it is a mineral acid because chloride is a mineral. Okay, next, Lucinga.
Oranges.
Oranges, yes, someone gave us oranges. Charity.
Lemon.
Lemon. Next, Patricia.
Onions.
Onions. Next, Paula.
Cherry mangoes.
Mangoes.
So I
Daphne.
was going to say coffee.
Not heard that.
Coffee, sir. Coffee has an acidic pH of 4.
Coffee.
Yes.
Okay. For coffee, it comes in after many reactions, but it's fine. Thank you, coffee. Daphne.
Teacher, what of passion fruit?
Passion fruits, yes. I'm picking the last two people. Patricia and then Nimanya, in case you have something that no one has said. Okay.
The acid in urine.
Urine. Okay. Urine, we take a lot of things. So in urine, we also have an acid. Okay, thank you very much for those contributions. Let's look at a few of those acids in our daily lives. Then we can continue. We have an acid in tomato juice. Someone gave us an example, vinegar. We have an acid in lemons, oranges, grapefruits, and many other fruits that are called citrus foods. That's citric acid. We have lactic acid that is in sour milk. Someone talked about it. In yogurt. We have tartaric acid that's found in grapes.
Daniela, please.
Daniela, can you sing for us something? Then we continue.
Hey, Daniela, we're waiting.
Okay, we have tannic acid in tea leaves. So students, what I need us to pick today is that acids are found in our daily, in the things that we take every day. We have formic acid in bee stings and some part of it in honey. We have hydrochloric acid in stomach juices. Thank you. So this shows us that in the things that we have around us, we have
Teacher,
acids in them. Yes.
is
Do you have
there
a
acid
question or
in
something?
ginger?
Ginger, yes. It is also sour. Okay, now, we don't need to cram these names now. This point is for us to know that in the things that we use every day, we have acids in them. The main idea that we are going to look at is some of these acids were formed by God because by the time a fruit was formed, this acid was added into that fruit or in that fruit. So we're going to say that those fruits that have acids, those acids that we find in maybe plants that are not manufactured by man, we call them organic acids. So organic acids, those are acids that are found in organic compounds. Do you have someone who can tell us what an organic compound means? When you say organic, if you go to a supermarket,
So can I try?
yes, if you go to a supermarket and you say, they tell you this section is for organic food, what do you understand? Yes, you can try. Go ahead.
An organic compound would be a compound that is like 100% natural, like no chemicals added.
Thank you very much. Thank you very much. I see more hands raised. Do we have a different answer? Johanna?
Oh, I have a question, but what I can say about organic, if I go to the supermarket and find organic food, I would know that they didn't use fertilizers and it was grown naturally. But then
Okay.
the question I have is, are acids only liquid? Because okay, if something has an acid, can't it be called acidic? Because as far as I know, baking soda has tartaric acid. So I'm a little confused.
Okay, thank you. Later, we're going to say that all these acids behave as acids when they are in a solution, when they are in water. Baking soda is acidic when it is in water, not when it is a solid. We are going to learn those ones
Excuse
later.
me, so I have a question.
Yes, go ahead.
This is about organic acids, right?
Yes.
So what I know, it could be wrong, but wine is made out of fermented grapes. So grapes are organic. So let's say after you get the wine and then people make like red wine vinegar, does the vinegar become an organic acid?
Yes, provided it, we can't say vinegar is an acid. No, it is acidic. It has some acidic component in it. And the acidic component in vinegar is organic. You understand?
Yes, sir, thank you.
You are welcome. These products, like when I say lemon, you can't say lemon is an acid. No. Lemon juice is acidic because in it has some component of an organic acid. Since we say that all these organic acids, they are not manufactured by man, they are created by God. So lastly, let's go to Rebecca Faith.
I
Do you have
wanted
a
to say
question?
that
You want
I
to
wanted
answer
to
something?
I wanted to say that organic compounds are compounds that are bound together that contain carbon and hydrogen bonds.
Okay, that is also correct, but So students, we have organic acids. Those ones we've seen that they are, I would say they are formed by God. Lastly, we have another section of mineral acids. Now, these are the acids that we're going to focus on in our chemistry, in our O-level chemistry. We call them mineral acids because they have minerals. That's number one. They have the radicals that we talked about. They have the hydrogen ions. So you will realize that all the time we're going to be learning about mineral acids. We don't say much about organic acids, but you just need to know that organic acids are also there. So what are mineral acids? Can someone tell us what mineral acids are? From this paragraph, can someone raise up the hand and read for us what amino acid is? Yes, Esther, what do you understand by amino acid?
I read that paragraph.
Yes.
Mineral acids. These are called mineral acids because they are derived from minerals. Examples include the common laboratory acids like sulfuric acid, hydrochloric acid, nitric acid, and phosphoric acid.
Thank you very, very much. So the reason why some books call them laboratory acids, because we are using chemicals in our laboratories. The radicals that we talked about, that table has radicals combining with hydrogen ions, and all those give us mineral acids. Thank you very much. We've finished. So with those are the two categories or two types of acids. Do you have any question or questions from that introduction of acids before we can go to detailed work on acids? Septa.
I would like to ask, do they use some organic acids to make mineral acids? Like, how are the mineral acids made?
Okay, thank you. For amino acid, we get, from what we've studied, we get radicals, a sulfate, or we say a substance containing a sulfate and a substance containing hydrogen ions. We combine them together. We do not use organic acids to form mineral acids. We use other chemicals, and in this book we've said we use minerals, carbonates, nitrates, sulfates. We use those to form mineral acids. Okay, let's go to the next part. Strength of acids. Now this is where we start from our O-level chemistry. Strength of an acid. We are going to be talking a lot about strong acids and weak acids. Now, we've also said that all these acids have hydrogen ions in them. So when we say that an acid is strong, that means that acid, or can someone try? When they say that this acid is strong and this acid is weak, what comes into your mind if I can tell you my point?
So can I try?
Yes, try.
When they say strong or weak acid, like what comes to mind is like one has a pH that's stronger than the other.
Can I try?
Q, yes. Number two, you try.
When they say strong and weak, what comes to my mind is that one is more reactive than the other.
Thank you. Lastly, Johanna.
When I hear strong or weak acids, what comes to my mind is that one of them can release hydrogen ions, produce them much faster, the strong acids.
Okay, thank you very much. All your points are very correct. We are going to look at them using pH values, but we'll do that later after understanding. Now, strong acids react faster. That thinking is also correct. But how do they react? They react by losing hydrogen ions. So strong acids lose hydrogen ions very fast. Now, weak acids, those ones that we say they are weak, they lose their hydrogen ions slowly, or they react slowly. Have we picked those main points? So when they say strength of an acid, they are looking at how fast this acid will lose or will produce the hydrogen ions. Those that produce hydrogen ions first, we call them strong acids. Those that take a very long time to produce hydrogen ions, we call them weak acids. Someone can also say those that react very fast are called strong acids. Those that react slowly are called weak acids because they react by losing the hydrogen ions. But for you to get our marks in O-level chemistry, you have to tell us that they are producing hydrogen ions. Is it okay? Am I still with everyone?
Yes.
Yes.
Okay, so I need us to look at those examples on my screen. I've put everything here to keep using many things at the same time. We are going to look at strong acids first. And I have 3 examples. And remember, you have to know that sulfuric acid is a strong acid. It will never change. How will it react? For it to be strong, you see I'm using this arrow. This arrow shows that the reaction has taken place completely. If you enter in an exam and you find a reversible arrow, we're going to talk about it. That means the reaction will not take place completely. And that shows that the acid is weak. But these acids with one arrow, full arrow, that show that the reaction has come to completion. It means that these acids are very strong. How many hydrogen ions do we have in sulfuric acid? By show of hands. You can see my screen. How many hydrogen ions, or how many hydrogens do we have in sulfuric acid? Yes, Rosemary.
We have 2 hydrogen ions in sulfuric acid.
We have 2 hydrogens. That is why in our equation we are having 2 hydrogens. You see that too? Next question.
Yes,
How
teacher.
many sulfate radicals do we have in sulfuric acid? Zora?
4.
4 oxygen atoms or sulfate radicals?
1.
Thank you. The radical is 1, which is a sulfate. So when acids are dissolved in water, when they are put in water, now you need to pick this item. When acids are put in water, when they are dissolved in water, they produce hydrogen ions. Remember, when they are not put in water, they will not produce hydrogen ions. But when they are put in water, they will produce hydrogen ions. Now, that process of producing hydrogen ions, some books say they ionize, other books say they dissociate. So you don't need to mind about those words. Other books say that ionizes. Other books say that dissociates. So feel free to use what your teachers will give you. What you find in our notes, you feel free to use that because they are used in all books. Now, let's go to hydrochloric acid. How many hydrogens do we have in hydrochloric acid? By show of hands.
1.
Perfect. How many chloride ions, chloride radicals? When I say, you remember our table. How many radicals do we have, the chloride radicals here?
1.
Perfect. That's why in this case, hydrochloric acid will produce one hydrogen ion. It will produce one chloride ion because in the formula it has 1, 1. Let me go to nitric acid. How many hydrogens do we have in nitric acid?
1.
That is number 1, 1. How many nitrate radicals? I think we remember. Nitrate radicals
1.
we have in nitric acid.
1.
We have some noise in the background. Thank you. So that means that sulfuric acid is producing its 2 hydrogen ions, hydrochloric acid is producing its 1 hydrogen ion, nitric acid is producing its 1 hydrogen ion. For you to confirm or to tell us that this acid is a strong acid, you use an arrow which is full. Have you heard that point? Use an arrow which is full. This full arrow shows that the acid is strong. If it is reversible, what does it mean? If we have an arrow which has 2 sides, 2 directions.
That it hasn't yet changed completely.
So what name do we give to those acids?
Weak acid.
Acid.
Thank you very, very much. So let's go to those weak acids. Do you see the difference now?
Yes.
Yes.
The difference is only on the arrow. You need to note down that the difference is only on the arrow. So let's start. Carbonic acid. How many hydrogens do we have in carbonic acid? By show of hands.
2.
You see 2? How many carbonate radicals do we have in carbonic acid?
1.
1.
Good. Let's go to phosphoric acid. How many hydrogens do we have in phosphoric acid?
3.
3.
How many phosphate radicals do we have in phosphoric acid?
1.
Next. Let's go to sulfurous acid here. How many hydrogens do we have in sulfurous acid?
2.
How many hydrogens do we have how many sulfides do we have in
1.
acid? Do you see how we are writing these equations after ionizing acids, after breaking acids? Then lastly, there is this acid. It is an organic acid. Now, for organic acids, the hydrogens that break off, that ionize, are only these hydrogens at the end. You see this hydrogen at the end of oxygen atoms, and this is the acid that we're going to look at. You see that it is one hydrogen, the one at the end, that has been released. Then the 3 hydrogens have remained with the original radical. That's why for it, we write it in this case. When we see these reversible arrows, what do you understand? That's my last question for today. What do you understand when you see these reversible arrows? By show of hands. By show of hands. What do you understand when you see reversible are
It is reversible.
Can go back to
reaction
the
can be
original
reversed.
form.
The reaction has not happened completely.
yes.
Reaction.
That it's a weak acid.
Yes, it is a weak acid. Thank you very, very much. Now you cannot talk. I've muted everyone. So those are the ones that we call weak acids. When they are dissolved in water, they do not completely ionize. Okay. Some
Excuse me,
of the acid molecules do not ionize. So you have like 70% of carbonic acid that will form the ion. Then the other 30% will not form the ion. That's why we say it partially ionizes. Some books say weak acids partially ionize. Other books say they do not completely ionize. Okay, that is it for today. Can you ask questions?
Excuse
Then
me,
we can
teacher.
finish our lesson from here.
Excuse me, teacher.
Yes, go ahead.
Teacher, instead of saying ionize, like let me say if they've asked you what is a weak acid, is it right to say that a weak acid is an acid that does not completely dissolve in water? Would it be right or it would be wrong?
That is wrong because weak acids fully dissolve in water. But even if they are dissolved in water, they do not completely break down. Okay, students, any other question? Maybe Johanna and Treasure, let me come.
Yes, teacher. My question is, okay, I'm a little confused as to why we have to put the 2 in front of the hydrogen and not above it. That's what I've not got.
Thank you very much. If you remember, what is the valence of hydrogen? If there.
One.
Okay, thank you. So we keep with valences here. Hydrogen has a valence of 1. It's what you write there. What is the valence of a carbonate? 2. What is the valence of phosphate? 3. What is the valence of a sulfite? 2. So the radical remains as it is. But in this formula of carbonic acid, how many hydrogen atoms do we have there?
2.
That's why we come here to put a 2. It's like we are balancing our equation. Okay, girls, last question. Is it Treasure asking?
Yes,
Already
teacher.
past time. Yes.
Teacher, I don't understand what you mean by ionize. Teacher, I'm confused.
Ionize meaning it forms ions. When it's breaking down, you see, we are forming charged compounds or charged things. Let me use that word. The hydrogen formed is charged, the carbonate formed is charged, the hydrogen is charged, the phosphate is charged. You see, we have a charge, positive or negative?
Okay.
Positive, negative. We have a charge, positive, negative, positive, negative, positive, negative. Since they are called ions, the process is called ionizing, ionization, ionizing.
Okay, teacher, thank you.
You are welcome. Students, that's the end for today's lesson. I've exceeded in our normal timing. I see we are already 3 minutes late. 3, 4. Yeah, 4 minutes late. So let's meet next time. I think that will be next week. We are working on these notes. We'll upload them.
Teacher, about the
Bye-bye.
eggs. Teacher.
Yes. Oh, yes.
Are we having
Go ahead.
exams after this week?
Yes. Exams they are meant to start from 29. The week after 29.
So please tell us you're joking.
Teacher, I'm not timetable yet.
Timetables are going to be released. We are reviewing them to see that there are no collisions here and there.
Teacher,
But you
they
receive
also
them when
objectives.
they are ready.
Teacher, from
We send you
29th
that.
up to what date?
Okay, let me answer one question at a time. The person asking the time papers take, you will see that when we release timetables, you will see the time that you will take to do those papers. So when those timetables are released, you see the time.
Excuse me, sir, I have a
the time you
question.
will take to do those papers. That's number one.
So I have a question.
Next question.
Paula, put up your hand like one else.
Yes, sir. I was asking, these exams, are they end of year exams or like end of term exams?
For now, we are calling them end of session exams because we are just coming to an end of this second session that we had of online lessons. So you shouldn't try to attach names. You shouldn't try to attach names to those papers. Just know after these lessons, we are going to have tests or exams, and that's it. Don't try to say end of year, end of term. Those ones will confuse you for nothing.
Mr. Arjunan, the exams are for 1 week.
If you have a question, you raise up your hand. Okay, thank you. The exams are for 1 week. Jovia and Daphne.
Teacher.
Yes.
May I wanted to ask that you say they are starting on 29th, which is the week, not next week.
Yes, you can confirm with your calendar.
Okay.
Are all acids aqueous, or are there some acids that have no water?
On the bit of science, we are going to continue studying next time. But when acids are concentrated or when they are not in water, they don't behave as acids. But you study that ahead. It's ahead. So they behave as acids only when they are in water. We are now answering questions on exams. We stopped our lesson. Our lesson ended, students. If you don't have a question on papers or any inquiry, then it's a bye-bye from this side.
Teacher.
Yes.
Teacher.